implementing all the functions that were required of us to implement so far in the HAL mini library. So some of you are probably wondering why is it still talking? Well, because I would like to go back right now to the test.c file and try to transform this draft of testing procedure into something that I can run automatically to ensure that my code is correct. Okay, like right now, if I increment all of those things, all of those tests, I'm going to have to enter things by hand. I'm going to etc. So if I want to test really the scan function, I don't have a choice right now. With the kind of test system that we're using, I will have to ask the user to type something. But besides the scan function, everything else, and I'm just correcting myself when I was talking, besides the scan function and the display function, everything else that I implemented should be testable without needing to display things on the screen or without needing to actually ask the user to type anything. So that's what we're going to try to do. So let me revisit this code here. I'm going to write a function void interactive test. Well, let's try to get a naming convention. Sorry about that. I just edited out sneeze out of this video. I didn't think you would like to have this burst your ears while you are listening to this video. So let me, as I was trying to say, let me try to implement a function here, test interactive. And this function is going to actually contain all the tests that requires the user to watch a screen or to enter something. I'm going to isolate them into a specific function so that later on, if I want to go ahead and retest this part of the code, I can do it. But I'm not going to do that when I try to run just blind test, okay? So int my array is declared, then I display it, I scan it, and I display it again. All right. So we took care of removing some of the tests, and I'm going actually to organize my code slightly differently. I'm going to put here the prototype of this function, and then I'm going to cut and paste it to the end of my file. So that's the first thing I see when I look into my file is actually the main. Okay, so we have test interactive out of the way, and I will choose here to call it or not by modifying the code here and then commenting this line. Everything else should be able to work without displaying things on the screen. Okay, completely work without any input or output. For example, this portion of the code here is testing the sort function. What do I need to test the sort function? I need a bunch of arrays. There we go. I have like 6 of them here. Then I need to be sorting each of them and comparing them to what? Comparing them to their sorted version. Well, that's good because I have a compare by position function. So instead of saying I'm going to test this array, this is the original array, I'm going to display it and then I'm going to sort it. I'm simply going to sort the array and I'm going to compare it to the sorted version of the array. So here is a variable called solution, which is an array of 3 elements, which I'm going to assign to the value 1, 2, 3. And now, each time I sort an array, I can say I want to compare it by position, and I'm going to compare my test array index n to the solution, since all of those arrays are containing the same value. I don't need to printf anything, I don't need to display the array. I have a way to completely automate here my testing, except that of course, let me have a little variable here called flag, a boolean flag. I'm going to assign whether true or false was returned by int array compare by position to flag, and I'm going to test this value. If flag is true, then I have no problem. I compared successfully my sorted array to the solution. If flag is false, then I'm going to display printf error sorting error. Well, okay, let me do it correctly. I'm going to display that there is an error. The error is when actually evaluating the interest sort function. Can I do something to provide more information to the programmer that's going to have to fix the problem about this error? Yes, I certainly can. I certainly can. I'm going to simply here open a curly brace, display my error message, and then I'm going to call int_array display to make sure that I display the content of my test array M and the content of my solution. So I'm going to display my test array index M, and size is 3. I'm going to display the solution, and I'm going to display the value of N. At that point, I might want to do a printf here, indent things, and say test array, test array number, let's go for it like this, number, and I'm going to insert here the number contained inside the variable N is, I'm going to just leave a space. At the end of this line, I will display my test array, printf expected solution was, expected solution was, and I'm going to display the solution I was expecting. So that should provide the programmer that's going to get a bug report from this testing system more information to be able to zero in into the problem. Okay, I'm pretty satisfied with this code. I'm going to take it. I'm going to go at the end of my file, and I'm going to call it test. Well, this is a test for int_array sort function. And I'm going to cut and paste my code right here. And there we go. Oops. I went one step too far. Okay, all of my code should be self-sufficient here. Solution, my test array is declared here, and it's declared. I call int_array sort, I call int_array display, etc. when I trigger an error. Okay, and that should be pretty much it. So let's see. Let's compile this code, make sure that it's syntactically correct. And then I'm going to test my testing function. I'm going to see if this code is actually capable to successfully execute all of the tests I wanted to execute. So now, knowing that my functions are correct, I'm capable to confidently modify my test to do the same type of test but with a different code. This is called refactoring. And I'm going to run again those tests. And if those tests trigger now while they were not triggering with the previous version of the code, then that means that I just introduced a bug right now. So let's go for it. GCC, couple of little error. My array is undeclared in test.c line 11. Well, yes, I've been moving things around, so maybe I move that as well. Notice that my file is not saved on disk. This is extremely bad. I'm going to make sure that I save it first. There we go. Now I'm going to recompile it. Sometimes you will observe a little delay that can be annoying. Okay, see, this was a false alert. I'm running my a.out testing compare by position. Okay, never mind. Go back to test.c. Might want to call this function actually in order to perform the test. So we have test interactive here. We have test int_array sort. I was half done actually, so I need to put the prototype over here, and I need to call my function here. That would be a little better, so I'm saving the file, waiting for it to be saved. GCC a.out. Nothing triggered, so we are good. Now, next, and I'm going to keep refactoring that code. I keep the same intent, but I am trying to actually make sure that everything is a little cleaner. One of the things I should be careful about is that when I do my test int_array sort, I'm actually relying on int_array compare by position to work. If I had a bug here, that might set off test array int_array sort to tell me that I have a bug with actually int-array sort, which is not the case. So, okay, I need to rely on this to be correct before to perform this test. All right, so let's find the portion of the code that is making sure that the comparison by position function works. Let's cut it. Let's put it into its own function, and let's use that function before I test int-array sort. So this would be void test int array, and this is compare by position. Rather long name, but at least it's explicit. I'm going to cut and paste my code here, and let's see how I can adapt it. Printf something. No, we don't want to do printfs. We want to do everything silent if we can. We have arrays 1, 2, 3, and 4. Okay, and we are using 1, 2, 3, and 4. So this is self-contained. Good news. We're going to clean those blank lines here. I'm calling compare by position 1, 1, 1, 2, 1, 3, 1, 4, and I'm expecting an answer, and I'm testing if this is what I get. So this is pretty much a very self-contained function here. So I can go ahead, make a copy of this, put the prototype up front, and before even I test int-array sort, I'm going to test int-array compare by position. If that one doesn't work, then because I use it inside of test int-array sort, I'm going to screw my result. So I'm saving this file, and I'm going to do a GCC. 1 is undeclared, yes, okay. This is because I removed here all the array that I'm using below. So since I didn't clean up this code yet, I'm going to comment it. I don't want that to be annoying me right now. I save, compile, no new line, end of file. This can wait a second. A.out, no error. I'll output it. My tests are functioning the same way they were functioning before, but the code now has been refactored. It's better written. Okay, go back to test.c. Let's get rid of this pesky no new line at the end of file. Well, since I am dealing with my test function, I might want to take this code that was causing me problem before and isolate it in its own function. So I cut this. I'm going at the end of my file. I'm going to have a void test. If I spell it correctly, this is better. Test int array compare by contents. This is what this function is going to test, and I'm going to comment my code, and I'm going to remove the printfs. I declare array 5, 6, 7, but I'm using also 1, 2, 3, and 4, so I need those arrays to exist as well in this function. I'm simply going to make a copy. So these are all the arrays that I'm using to test. Okay, and this is my test function. Well, let's save. Add a new line at the end of the file so that the GCC compiler doesn't complain. Once the file is saved, we go back to Conqueror, GCC, a.out, still working. Test.c. We need now to take this new function, add its prototype up front, and invoke it. This new function is using also compare by position. So I would not call it before to actually have called the test for compare by position. So if this works, then I can test by contents, and I can test int-array sort, etc. So I'm saving my file. We are going to recompile again, run again. Everything is working so far so good. What do I have left in the main that needs a little bit of refactoring, a little bit of cleaning? Well, I have a block of code up here that is testing the isSorted function. I might want to do that before to test the int-array sort function because it's using it. Okay, so let's do that. I take this code, go at the end of my file, and I'm going to have a void test int-array isSorted. Opening curly brace, cut and paste, closing curly brace, empty line at the end of my file to appease GCC, remove my printfs, and I'm calling isSorted on my array 9, and I display whether it is in ascending order or not. Okay, I was assuming here that the user would provide me with an array. I don't have that anymore, so instead, let me go ahead and take here array 3, for example. I'm going to rename it 1. I want to make sure that this function can detect whether an array is sorted or not, so that should be relatively easy. Let me take an array 1, which is going to be the sorted one, and an array 2 that is going to be the not sorted one. So for example, 5, 3, 2, 1, 4, 0. And actually, let me go ahead and change those names. This is going to be named sorted. This is going to be named unsorted. Let's not hesitate to make things clear. So the size of those array is 6. If int array sorted of sorted is true, we have no problem. No quarrel with that. If it is false, then I need to display error. Int array is sorted on array unsorted array. So this is what triggers my error. Okay, I'm trying to call int array is sorted on already sorted array. Well, I don't know if this is really what matters is that you can identify where it comes from the code, but let's be like ultra specific in already sorted array. So anybody can read this code, this error report, and understand what's happening. The second thing we're going to do is, let me see, if I call int array is sorted on unsorted, I would expect a false. So if I get a true, once again, I have a problem. Error, int array is sorted on unsorted array. Okay, well, I tested like the two basic cases that can occur. I'm going to save, waiting for the file to complete saving, then compile, then execute. Still working. So I'm not modifying the semantics, the meaning of this code. I'm just actually refactoring it. Now, did I call it? No, once again, I forgot to call it. Wow, this is becoming a routine. So that will teach me to jump to conclusion. I'm going to put my prototype here. I'm going to call my test function here. I call it before sort because sort is using is sorted. And this time I'm going to recompile and run again. And I will be able this time to say something about the result of this one. Okay, what is left in the main that I might want to move around? Testing the int array search function. So all this interactive stuff is going to go away. We need a value at some point. Well, we could assign a value to v. And then we are going to try to search in an unsorted array, try to search in a sorted array, and we are going to have to add something here. We're going to have to take 3 cases into consideration. I have the value v. I'm looking for it in an unsorted array. I'm looking for it in a sorted array, where it is. I'm looking for it in a sorted array where this value doesn't appear. So 3 cases. I'm taking all of this code. I already wrote the call this time to this new function, and I'm going to write here its prototype, search, and I'm going to take this prototype and I'm going to cut and paste it here. Actually, I'm going to retype it. If I try to cut and paste it here, I'm going to lose my previous cut and paste. So int array search. Here's the code for my testing and an empty line at the end to make GCCRD. Let's see. We are going to use a variable, let's call it value. Value to search would be even better. Value to search is going to be, let's say, 3. Now, int result will be always the result of calling the search function. So I'm going to declare it once and for all. Then I need an array. So I'm going to make my own array here. I need 3 different array, right? So an array that I'm going to call unsorted, which is going to be initialized to, let's say, 0, 6, 5, 4, 2, 3, 1. So 1, 2, 3, 4, 5, 6, 7 value. No, I don't need that many. Say just stop here. 1, 2, 3, 4, 5, 6 value should be plenty. So I'm going to have a test array of size 6, okay? One that is unsorted, sorted with value inside. Long name, I know, but they are clear. So 0, 6, 5, 4, 2, 3. Then int sorted without value inside. This makes it somewhat easier to read your code, your conditionals, and make sure that it makes sense. So I'm going to use 0, 6. And I just realized that I was pretending that those arrays were sorted. So instead, I'm going to actually sort them. 1, 2, 3, 4, 5. Sorry about that. Let me just remove the end of this line. So I have an array of size 6 here, where with the value 3, and I'm going to have an array that is sorted as well. 2, 4, 5, 6, which do not comprise the value 3. Value to search is here, result is here. I'm going to move those first. And then I can start making my test. So int array search, I'm searching for the value to search inside of array unsorted of size 6. What do I expect? If result equal -1, that's what I expect. So if result different than -1, that means my function failed to detect that the array was not sorted. So error, int array search, without typo is even better, did not detect unsorted array. Pretty explicit. Then, remove that printf, int array search of value to search. Inside of this time I'm going to work with sorted with value inside, which is of size 6. And this time I'm going to say, well, if the result is different than, if the result is different than, well, I'm searching for the value in an array that has the value, so if it is different than 1, I think is what has to be returned, which is true. Error, int array search did not find value. In an array containing 8, I could add. Let's keep it short for now. Last case, I'm calling array search with value to search and sorted without value inside. Size is always 6. And this time, if result different than, I should get 0. Printf, error, int array search did find value. Little bit of aesthetic thing here. I don't know why, but heading white space everywhere. So I'm going to remove these, save, and I'm going to compile to get rid of compilation error right now. Results then declared where result has been probably pluralized at some point and it should not have been. So let's go back to the code. Yes, results is supposed to be singular. So save again, wait for the saving to take place, then move and recompile, execute. Segmentation fault. Well, this is not good at all. Let's go back to the last thing we modified. Apparently there is a problem here. Segmentation fault mean pretty much pointer error, which means also we probably have an array that we are exploring out of boundaries. We are iterating outside of the boundaries of an array. So let's have a look at what we did here, because these tests were working before, and now after refactoring them, we don't have them not working anymore suddenly. So let's start by checking size issue. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 element. 1, 2, 3, 4, 5, 6 element. Okay, all of these arrays are of size 6. When I call the search function, I specify size 6, 6, and 6. I specify value to search as the first parameter, which is correct. Then I specify the name of the array. What is the error that we got? Segmentation fault, but we don't know where we got it. So it's difficult for me to tell you right now if this is where it happened, or if this is where it happened, or if this is where it happened. Okay, that's easy enough. We are going to use a good old printf, okay, and I'm going to just display on the screen a tag, meaning, hey, I'm here. This is what I did. I executed the code up to that printf without a segmentation fault. So that's going to give me some information. To make sure my printf appears on the screen before the crash, I'm going to flush the standard output. I'm going to make sure that the operating system displays this message on the screen before display it immediately before to go to the next instruction after flush. And I'm going to display here 2. So if I see 1 on the screen, that means all of this work. If I see 2, that means everything up to here work. And then that would let me with this last possibility for an error here. Let's save. Let's see what this is bringing us as information. The file is saved. I recompile. Execute. 1, 2, segmentation fault. Okay, this is getting clearer. So everything here is working correctly. 1, 2. So if my hypothesis is correct, up to here everything is correct. So when I call this iterate search function, something goes wrong. So I'm going to make a final print here and make sure that I never reach it. If I reach it, that means something goes wrong when I return from this function. So this is a problem in the main. This is not a problem with my function. Proceeding by elimination. Segmentation fault, so yes, the hypothesis is confirmed. My problem is right here, somewhere in here. So let's have a closer look at what's happening in this code. I'm calling iterate search with value to search, and this array sorted without value inside. Sorted without value inside is an array which is initialized with 0, 1, 2, 4, 5, 6. So when I fail to find the value inside of an array, this is where my problem emerges. That's what this debugging session is telling me. So let's switch to actually our implementation, and let's see if we didn't thoroughly test it enough our dichotomic search function, which appears to be the case here. Okay, so I'm going back to our implementation. We are our search function. We were pretty satisfied with it, except that we kept having this open question: should I try to check if stop suddenly becomes smaller than start? Can that even happen? So now that this little question has been in suspension for long enough for you to try to figure it out, well, we are going to close this topic and figure this definitively. We have now one test that is telling us something is wrong with this search function. This test is calling the array 0, 1, 2, 3 is missing, 4, 5, 6. Let's try to figure out what happened when we call that function with this array. To do so, I'm going to, once again, this is the same routine that applies every time you try to debug. You are going to have to gain information about what's happening. How do I gain information about what's happening here? Well, I'm going to display every time this function is called. I'm going to display something like search function call, and I'm going to display the value for start, the value for stop, and the value for middle. And then I go to the next line. Oops. Okay, so that means I need the variable start, stop, middle, and I should be good. So I'm going to put this on the next line for readability, sorry. I'm going to save, and I'm going to run my code with this inside. GCC is okay, a.out, and I have here, and I have near an infinite loop. Okay, I had to do Control-C to stop my program. Apparently my segmentation fault was not due to me getting out of the boundary of the array, but as far as I can scroll up, I see that here my recursive function keeps calling itself with the same parameters. Until what? Until I run out of stack, pretty much. And this is what caused the segmentation fault in this example. So segmentation fault can have a different meaning when you're dealing with recursive function. For now, let's try to investigate this further. When start is equal to index 2, when stop is equal to index 3, middle is equal to index 3, my function keeps calling itself repetitively. Well, test.c is telling me that I'm calling my function on array 0, 1, 2, 3, 5, 6, looking for value 3. So I'm going back to the code in harl.c, and now I'm going to try to analyze my function and figure out what's happening. Well, here's what is happening. I'm going to take a piece of scrap paper here. Okay, and I'm going to investigate this further. So this is not really part of exercise 804 since you get it here. This is more debugging of the dichotomic search function. So here is a case that is making me fail my test. Start is index start is equal to 2. Stop is 3. Middle is 3 as well. Let me remove this here. Typo. Okay. Middle is 3 as well. This is infinite recursive call. So let's try to trace through the program, to see what happened exactly. I'm going to reduce this a little for now so that I can see my code, and I'm going to scroll up so that I can have a part of my screen for my notes. So this is my recursive function on top. These are my notes at the bottom. My first call, I'm going to write it as, okay? My first call passes the value to search, which is a value 3. This is not going to change. I'm not going to write it down. It passes array, which is 0, 1, 2, 4, 5, 6. Not going to change. I don't write it down. What is interesting is that my first call is going to have the start at 0 and the stop at size minus 1. Size of this array was 6, minus 1 is 5. This is my first call to that recursive function. What happened when I handle this call? When I handle this call, is start equal to stop? No. So I don't execute this return. Middle is computed. Middle is going to be equal to stop minus start. 5 minus 0 is 5. Plus 1, 6 divided by 2 is 3. Plus start, which is 0, is still 3. Then I'm going to display this on the screen, which we didn't see because it scrolled really fast. And then I'm going to test, is data index middle data index 3? Let me remind you that my array is 0, 1, 2, 4, 5, 6. 5, 6. So this is index 0, 1, 2, 3, 4, 5. Okay, now that this is clear, I'm comparing here data index middle, data index 3, which is equal to 4. Is 4 equal to val, which is equal to 3? No, I don't execute this return one. Is data index 3, which is equal to 4, lesser strict than val, which is equal to 3? No. So I call myself recursively using the code at line 67. And my call becomes search for val. Val is still equal to 3. Search for val in that array. This is still my array. Using start, 0, and middle equal 3 as boundaries where to search. When I run through the code, now I have a recursive call. I go back to line 58 with start equals 0, stop equals 3. Are they equal? No. Middle is going to be this time equal to what? Well, stop, 3 minus start, still 3, plus 1, 4 divided by 2, 2 plus start, still 2. So my middle is now 2. Is data index middle equal to val? Well, let me see. Data index 2 is equal to 2. Is it equal to val 3? No. Is it lesser strict than val? Yes. So I'm executing the recursive call on line 66, which means I call with val data and change middle and then stop. And this is where I hit my infinite loop. When I execute again a recursive call here, start is now 2, stop is 3. Are they equal? No. Middle is going to be equal to stop 3 minus 2, 1 plus 1, 2, divided by 2, 1 plus start 3. Middle is equal to 3. And then what happened? Data index middle equal to val. Data index 3 is equal to 4. Is it equal to val? No. Is it lesser than val? No. So I'm going to keep calling myself recursively using again the same value for start and stop that I had when I came into this recursive call. So this is where we get stuck. Okay, so now the question is, how do we get out of this? Well, first thing I would suggest is, since we test whether middle is actually our solution, we test it on line, let me see, on line 65 we test whether middle, the element at index middle, is equal to val. Since we rule out that middle is going to be the solution, we need to restrict our array. We are stuck in a situation where our array, our subarray to explore is going to be always the same thing between index 2 and between index 3. So to get out of this situation, let's say that when I want to explore every element to the right of middle, I'm going to start at middle plus 1 and to stop. When I want to explore every element to the left of middle, I'm going to start with middle minus 1. Which brings us now to the situation where maybe we are going to have those index cross one another because we are skipping one, we are going right or left to the middle element every time. Therefore, I'm going to add a quick test here, which is stating that if start is actually greater than stop, well, I should return 0. I didn't find your value. I'm going to save this code. I'm going to go back to Conqueror. Let's compile again. Let's execute. Search function call from 0 to 5. That was our initial call. The middle is 3. From 0 to 5, the middle is 3. I'm not sure why this is returned twice. I'm going to double check this. Then from 0 to 2, middle is 1, and then we found our solution. So let me see real quick. All.c. We're going to trace that just to double check everything is alright. We don't have every single call here because, of course, if this or this trigger, we have a direct return. Okay, so I'm going to add another printf here saying calling with start equal %d, stop equal %d. I'm not going to go to the next line. I'm going to display the value of start and stop. And then if I reach this, I'm going to display the value for middle. Middle equal %d as well. And there here, I can remove 2 of those variables and just keep those variable middle. So this is going to give me a better view of what is going on here. GCC. Hope my file was saved correctly. Yes, okay, the new version was saved, so I have more information here. Here is what happened. When I search for 3 inside of this array, my first call is start 0, stop 5. Middle is going to be determined to be 3, and then I'm going to look at whether data index, let's look at the code itself, okay, to double check. I'm going back to whole.c. I've been displaying here 0, 5, and 3 so far. So start is 0, stop is 5, and middle is 3. I'm checking if data index middle is actually equal to val. Data index middle is data index 3. This is equal to 4. If you follow with your array on a piece of paper, that would be easier. So this is equal to 4. Is it equal to 3? No. Is it lesser string than 3? No. So I call myself recursively with this time index start, which is 0, and middle minus 1. Middle was actually 3. So I'm calling with stop equal 2. And I'm going back up here. So now I have a recursive call of the search function with start equals 0, stop equal 2. And I go through the same routine. Let me go back to the screen here to make sure that we are in sync with what the trace tells us. We have a double, okay, this is odd. We have a double display here of what's going on. Let me try to figure this one out because I don't see it in the code. So give me 1 second here. Okay, since I'm not sure what's going on here, I'm going to rewind 1 step to test, and I'm going to remove that flush here. You notice probably that there was a 1 displayed at the end. It doesn't add anything to our trace because now we know that everything is working. I don't want to have a f-flush pending anywhere in my code when I have problem with my printf, so this is why I'm removing it. I am going to recompile just to make sure, and I'm going to rerun my code here. Okay, so I need to add obviously a \n here if I don't display middle. This trace is okay except for this double displaying here of 0, 5, and 3, 0, 5, and 3 case. So I'm going to fix this little glitch, and then I'm glitch here, and then I'm going to come back to that. When I am in hall.c, if I reach here, well, this is not going to be easy to fix actually. If I reach here, I'm displaying the middle. If I don't reach here, I'm not displaying anything. So the only way I can think of to easily fix this problem is to put a \n here, so that this ensures that I go to a new line every time I display calling with start and stop, and I go to a new line, an extra new line I should say, every time I display middle. So I'm going to remove that extra new line, and instead, when I'm done with my search, I'm going to display a \n. So that would be right, not right here, that would be actually in the test.c. I'm going to remove that \n afterward, but right now I just want to make sure that I have a clean display. So I'm going to go back here. This is the last test that was causing us problem. Display a \n which is just temporary, and go back to recompile my code. And then a.out. Okay, I have a clean trace, except that I still have those two calls. So now I'm going to go back to starting with test, and I'm going to follow exactly step by step to try to figure out where this call is happening. So let's go back to test.c. Okay, here's where the call start. And actually, okay, I just grabbed it. Actually, what's happening here is that we are focused on this case. However, by instrumenting, by adding some printf to the search function, well, that means that it has been also added when we call it above. So, in a nutshell, if I command those test here, okay, if I command those test and save my code, I will run only one call to this function, which means unused variable, that's fine, which means that when I run it, I will have only the trace of one of those test function. Before, what was happening is that, well, the first call was leading to an immediate error, and the second call was leading to one recursive call, thus explaining why we had on the screen another line, an extra line, saying that we were calling with 0 as start, 5 as stop, and middle as 3. This was what was happening here when we were invoking for the second time in this test interarray search function, the interarray search function. Okay, so well, that's one mystery cleared out of the way. This is better when you have anything that you cannot explain appearing in your test to investigate it thoroughly. Most of the time, this is going to be something silly, like we just encountered. But nonetheless, do not leave a test which is displaying something that you cannot fully explain, and move to the next assignment, because that would be completely counterproductive. It's actually more productive for you to spend that time, chasing your tail maybe for 5 minutes, than to actually jump to conclusion and not make sure at 100% that your tests are meaningful to you. So, well, we're pretty much done. I'm going to clean up the code now by removing this extra debugging information that I had. I'm going to compile to make sure I didn't break anything syntactically and run again my test to make sure I didn't forget anything. And this is pretty much it. We are at last, at the end of the refactoring of our test function. And as you could see, that allowed us to go back to our dichotomic test function and solve a question that we had pending for almost this whole series of exercises.